Oink. Oh, hi there, everybody. Welcome back for another amazing video. Woof, woof, woohoo! Woof, woof, woo. My friends. Whoa, whoa. Oopsie. Sorry, Stretchy. No, it's okay. I'm fine with it. Hi, guys. My name is Stretchy. Never would have guessed. Yeah. And today, we are going to be learning about prisms. Prisms? What exactly are prisms? That is a very great question, Frenchie. Prisms are a solid figure with two congruent parallel bases. Examples of prisms include the ones that are shown right here. So basically, all of these are prisms. All of them, but they're different sizes and different ways around. Not all prisms have to be the same size or have to be the same shape, because all that matters is two congruent parallel bases, and as long as it has those bases, it is considered to be a prism. But what's a base? That's another great question that Byron just brought up. The base of a prism is one of the congruent parallel faces that the prism has. So these, highlighted in green, are the bases because they are both congruent and parallel. So, in case you were wondering, yes, these are the bases of the prism, which means that all of these, shaded in blue, must also be bases because they are all congruent and parallel. Make a rectangular prism from a net. Wait a second. Where did we suddenly get a butterfly net? There are no butterflies around here. Silly Byron. That's not the kind of net we're talking about. What? Then what net are we talking about? We are talking about a 2D visual representation of 3D shapes, which is a net. A net is a two-dimensional flat pattern that can be folded into a three-dimensional figure. So basically, a net is a 2D representation of a 3D shape, but completely flat. So an example is this net right here, with a rectangular base and 4 triangles. This is the net of a rectangular pyramid, and pyramids are what we are going to learn in another video. But meanwhile, let's try to see how this forms into an actual pyramid. So this highlighted in blue is the base, meaning that the rectangle must be at the bottom, because the triangles, once folded up and connected to each other, make the pyramid. But how exactly? Well, the rectangle stays where it is, but meanwhile, both pairs of adjacent triangles, or basically two pairs of triangles that are the closest to each other, like next-door neighbors, hello, they fold up, and then once they do that, they connect to each other. This forms a small wall. The other two triangles do the same thing, and once all of these triangles connect together, they all touch at a certain point, making a pyramid. So basically, the triangles merge together, and the rectangle doesn't do anything because it is the base. So, that is how it forms. And if you want to make it into a net again, basically detach the triangles, and it would look exactly the same as before. So, yep, it depends on what kind of net it is, because if it is not the right net, then it is not the right pyramid. Yes, because if this was a triangle instead of a rectangle, it would be a totally different pyramid, and it would not be a rectangular pyramid. Ah, see now? But also, in a prism, there are 4 other faces that are not the bases, and those 4 other faces are known as the lateral faces. A lateral face is a face that is not a base. Prisms have rectangular lateral faces, and pyramids have triangular lateral faces. So, this pyramid has a triangular lateral face, and this prism has a rectangular lateral face. Every prism has rectangular lateral faces. No other shapes. The lateral faces of a prism are always going to be rectangles. So let's take a look at some of these objects. The flat rectangular sides of a prism are called faces. The line segment where two faces meet is called an edge. So if you look carefully here on this cornflakes box, there are two faces, one big and one small and thin. However, between those two is a thinner and smaller line. That line, which is really also known as a side, is also known as an edge. One edge makes two faces of a prism meet, making those two adjacent to each other, or closest to each other, like next door neighbors. Hi, hello. They are adjacent to each other because this edge helps both of them meet. How many faces does a rectangular prism have? No clue. Don't worry, Byron. It's actually not that hard. We just have to look at one rectangular prism, any rectangular prism to be honest, and count all of its faces together. This is a rectangular prism. A rectangular prism is a solid figure with two rectangular bases that are congruent and parallel. So if we look here, these are rectangular bases that are the faces. So they are faces. 1, 2, that makes two faces. But then there are also a top face and a bottom face, which makes 4 faces. Then comes the front and the back faces, which makes 6 faces. So a rectangular prism has 6 faces altogether. Now, usually, the bases of any prism are at the top and the bottom. But in case of this rectangular prism, the bases are from the left and the right sides of the prism. So the bases don't always have to be at the top and bottom. What matters is, if the faces are congruent and parallel at the same time, then they are bases. So, all that matters is congruency and whether or not they are parallel. If they are not congruent or parallel, then they are not bases. That's common sense. So, a rectangular prism has 6 faces. And, in case you were wondering, a face is any flat surface on a 3D shape. The face of a prism is any of the flat surfaces of a prism. So, for example, we can see that in this prism, the rectangle is a face because it is a flat surface. So, yep, there we go. But then there are also the lateral faces. And the lateral faces, again, as we mentioned, are faces but are not bases. So, if we count the bases, which make 2 faces, plus the 4 lateral faces, which make 6 faces, we add them up to make 6 faces. So a rectangular prism has 6 faces. But how many edges does it have? Well, it's actually quite simple as well. If one edge makes 2 faces meet, then 6 faces have to meet at how many edges? It's like a multiplication problem, sort of. 1 times 2 is 2. But if there are 6 faces, then what is 6 times 2? 12? That's right, my brother! Rectangular prisms have 12 edges, and all of those 12 edges make all 6 faces meet. This means that every two faces are always going to be adjacent because they are met and literally the closest to each other, like next door neighbors. Hi, hello. And not only that, but also shapes that are adjacent share a common vertex. So if they do not share a common vertex, or if they share a different vertex, if one shares one vertex, but the other shares a completely different vertex, then they are not adjacent because they have to meet at a common vertex. So, this is the common vertex that they meet, and this is the other one. In case of the top and the front, this is the vertex. In the case of the top, not the top, sorry. In the case of the front and the right faces, this is the vertex. So, there are 12 edges in a rectangular prism. Two parallel faces of a prism are called bases, and the faces that are not the bases are called the lateral faces. Wait a second. What shape are the bases? It's a very great question. Well, we could look at one object here, which looks like a rectangular prism from a certain view. So this is a rectangular prism because it has 6 faces and 12 edges. But what shape are they exactly? So, if we count up the front and the back faces, which in this case make 2 faces, then we could see that there is also a left and a right face, which makes 4, meaning that there must be a top and bottom face, which make 6. And from here, all of the faces look like rectangles. So, the bases are shaped like rectangles, and this means that the lateral faces are also shaped like rectangles, because like I said, all faces of a rectangular prism are rectangular. So, this is a rectangle, which means the bottom must also be a rectangle. This is a tall, thin rectangle, which means that this must also be a tall, thin rectangle. This is a rectangle, which means that this also must be a rectangle. So all of the faces are rectangles in this case. The bases are shaped like rectangles, and the lateral faces are also shaped like rectangles. However, if we look over here, one of the bases looks like a square. A square? Excuse me? A square base? Yes! Rectangular prisms like this one could have square bases. Square bases what? Wait a second. So you're saying, you know how all squares are rectangles, Oregon? Yeah. So if all squares are rectangles, which is absolutely true, does this mean that all square prisms are rectangular prisms? Actually, you're not wrong. Yay! Woohoo! There is such a thing as a square prism, because in order for it to be a square prism, it must not only have 4 lateral oblong faces, and by the way, oblongs are rectangles that are not squares, but it must also have 2 square bases. So, Byron's right. All squares are rectangles, which means that all square prisms must be rectangular prisms. So this could be a rectangular prism. And this could be a rectangular prism. All that matters is if the bases are either squares or rectangles, then it is a rectangular prism. A square prism has 2 square bases, and as long as they are congruent and parallel at the same time, they are both bases, and this is considered to be a prism, because if it does not have bases, then it is not a prism. So, a square prism has 2 square bases, and a rectangular prism has 2 rectangular bases, which could also be squares as special cases, because all squares are rectangles. However, if we look into this object right here, wait a second. None of the faces are oblong rectangles. That's right. All of the faces of this shape appear to be the same shape. A square in each face. What kind of shape is that? Well, a three-dimensional shape where all 6 faces are squares and not oblong rectangles is known as a cube. A cube? I think I have heard of a cube before. Yes. And a cube is a rectangular prism with 6 congruent square faces. It's a prism? Yes, I just actually started learning that today. Very cool. So cubes are a special kind of prism because, although it may not look like it, they do indeed have bases and lateral faces. It's just that all of the faces are the exact same shape, usually in a square prism or rectangular prism. Both pairs of adjacent lateral faces are different sizes and are usually have sides of different lengths. But in a cube, every face is equal. So this means that if only one side length of a cube were to have 3 meters, then the area of one of the faces of the cube must be 9 square meters, because 3 times 3 is 9. Yes, a cube is a special kind of prism that has all faces equal, all faces congruent, and all faces parallel. But that does not mean that all of the faces are bases. Be careful over here. In this case, the bases are the top and bottom, and the lateral faces are the front, back, left, and right. But first, we need to explore how the square, rectangular prisms and the cubes are made. So, how are the cubes, rectangular prisms, and square prisms made? Well, the kinds of nets are different because they are different prisms. The net of a rectangular prism looks like this. This is the net of a rectangular prism. Now, this is a regular rectangular prism because, as we could see here, there are 2 rectangular bases and 4 rectangular lateral faces. 4 of them. But if we look here, this is the net of a rectangular prism. Look at this. The 2 blue rectangles represent the, let's see over here, they kind of represent the bases. Yes, because if we were to fold and connect all of these rectangles together, there is 1 rectangle left over, which would then be hinged up by this rectangle, and then it has no other choice but to dangle at the top and connect to this rectangle, making this rectangle be at the top, and this one be at the bottom. So the blue rectangles could be thought of as bases because they go on the top and bottom. But on this case, they are at the front and back. All that matters is, if they are both congruent and parallel, then they are bases. So, the blue rectangles represent the bases, which means that the 4 other rectangles must represent the lateral faces because they are not the bases, right? Yeah, that one's pretty obvious to point out. The left and right and the top and bottom faces of this rectangular prism are lateral faces because they are not the bases. Yes. So, the net of a rectangular prism looks like this. Ooh, it kind of looks like a small, thin rocket ship. But either way, the net of a rectangular prism could really be cool. And plus, if we apply the fact that all of the faces of a rectangular prism are rectangles, then we can assume that all of the rectangles in the net are rectangles indeed, because they all have two short sides and two long sides, which means that they are all oblongs. Oblongs are rectangles that are not squares. Yes, so any rectangle that is not a square is called an oblong. An oblong, an oblong. So, this is the net of a rectangular prism. This looks very nice. But that's not all. A rectangular prism also has 8 vertices. 8? That's a lot! Yes. And in the 12 edges, 3 edges intersect to form right angles at each vertex. Wow, that's true. Because if we look over here, those are 3 faces. But if we look over here, that is 1 edge, which makes them meet. And that's a right angle, because all rectangles have right angles. Wowza, that is very cool. Shapes are magic. No, silly, they're not magic. They're wonderful. But could they be magic? Sort of. Let's just continue on. Okay. So, yes, this is the net of a rectangular prism. However, the net of a square prism is different because 2 of the bases are squares. So, if we look over here, this tells you information about a square prism. A square prism is a 3-dimensional cuboid in which the bases are squares. Cuboid? Huh, that's a new word. What is a cuboid? That's a great question. A cuboid is a kind of rectangular prism because it looks like a cube but elongated. So, it's a cuboid. Yes. So, a 3-dimensional cuboid could be a square prism or a rectangular prism or a cube because a cube is a prism. So, a square prism looks like, not exactly this because this is an oblong, but it may look like this. So, this, the creator of this square prism tried to draw it the very best, but I don't think that's a square. Either way, it really must look like, this, kind of. So, because this is a rectangular prism, and all square prisms are rectangular prisms. So, this is kind of what a square prism should look like, not with the oblong rectangles, but with the squares. The net of a square prism is completely different. It is kind of shaped like, I don't know, maybe a large tile floor with 2 extra small tiles on it. But either way, the net of a square prism is different because all 4 of the oblong rectangles are lined up. And the 2 square bases, 1 square base is only on top of 1 oblong. And the other is only at the top of 1 oblong. However, if we fold them together and if we connect them, this would make 2 rectangular faces. And then the squares would come along, and then they would go either on the left or right, top and bottom, or front and back. All that matters is, if they are both congruent and parallel, then they are both bases. Usually, the bases are the shapes that are smaller in the net. So the shapes that are bigger are known as the lateral faces. But this is not in the case of a cube, because a cube has all faces the same size. So, and the same length, too. So, if we fold all of these shapes up, the square prism should look like this. So, yes, this is the net of a square prism. This looks completely different compared to the rectangular prism net. And square prisms are very cool shapes to see. But there are two types of square prisms. Ah, there we go. That looks more like a square prism to me. Two, 4 sides, the same length. There are two kinds of square prisms, a right square prism and an oblique square prism. A right square prism is a square prism with a right angle. However, an oblique square prism is a square prism with an acute or an obtuse angle. So, an oblique square prism is a prism with an obtuse or an acute angle. So basically, an angle that is not a right angle fits into the description of an oblique square prism. That's the same for all other prisms, such as rectangular prisms. So, this is the square prism. And the square prism is really a true fascinating delight. But the cube is really a powerful delight because this time the net of a cube looks like the letter T. It looks like a lowercase letter T. Do you agree? It kind of also looks like the cross that Jesus died in. He was crucified by the Romans. Man, but at least he died for a good faith, for our freedom. But anyways, enough about that. Cubes have all 6 faces, congruent and parallel squares. So if we look over here, all of the shapes of the net of a cube are the same size, and they are also the same shape, which means that they are all squares, not oblongs. Be careful. Oblongs are rectangles but are not squares, and squares are rectangles but are not oblongs, so be careful. The net of a cube looks like this. So, because if we fold these up, they would make a sort of cube-like shape with room for one extra square, which hinges and goes on top of there. So that the cube looks like, hang on, let me just get the cube real quick. The cube. So, when all of the squares of the net of a cube form together, the cube looks like this. The cube looks like that. With all faces the same length, all faces the same shape, and all faces the same size. So, this is a cube, by the way, because it's 1, 1, 1. It's 1 for all of it. So, the same. It's always going to be the same, because squares always have the same lengths. It's a rectangle with all 4 sides the same length. So that is the net of a cube. However, that is only part of the concept fully understood, because just like all other shapes, rectangular prisms, square prisms, and cubes each have their own unique formulas. What? Let me show you something new. Let me present surface area. Surface area is the total area of all the faces of a solid figure. So, to find the surface area, we cannot just find one face of the prism. We have to find every face of the prism, which could be tough work. However, there are easier ways to find the surface area, so that the formula could be shorter, but still complex. This is a right rectangular prism because it has a right angle, and all of its faces are rectangles. See? If you look over here, the front and back, top and bottom, left and right, they are all rectangles. And if we look over here, you could see this formula. That is the formula of how to find the surface area of a rectangular prism. The surface area of a rectangular prism is 2 times WL plus HL plus HW. So in other words, it is basically just 2 times the width times the length plus the height times the length plus the height times the width. So in the parentheses, we see 2 W's, 2 L's, and 2 H's. And since one variable multiplied by itself equals that variable squared, the formula could also be written as 2 times W squared plus L squared plus H squared, because W times W is W squared, L times L is L squared, and H times H is H squared. So, either way, the formulas are the same exact thing, just with different formations. So, if we look at this rectangular prism, the L stands for the length, or how long one of its side lengths is. The W stands for the width, or how wide it is. The H stands for the height, or how tall it is. And since it's a 3D shape, it has 3 dimensions: length, width, and height. So let's substitute the L, W, and H for whole numbers. Let's see. Let's pretend that the length is 6, the width is 2, and the height is 4. We should get an answer of 88. Hang on, how did we get 88? That's a great question, Byron. Keep asking questions like that, because there is an easy way to solve this problem. And if you don't know how you got that answer, then you must have done something wrong, or must have done it too quickly. So, how we got 88 as our answer? How did we get 88 as our answer? We got 88 because we knew that the surface area is 2 times WL plus HL plus HW. So if we do a little bit of math, I know, so frustrating. The W is 2 and the L is 6. WL is W times L, so 2 times 6 is 12. Then 4 times 6, which is 24. 12 plus 24 is 36. Then 4 times 2, which is 8. And 36 plus 8 is 1, 2, 3, 4, 5, 6, 7, 8, 44. And if we multiply 44 by 2, we get 88. Because 44 times 2 is equivalent to 44 plus 44, which is 88. So 88 is the correct answer for the surface area of this rectangular prism. So 88 is not the area of one face. It is the area of all of the faces together. Yes! And since faces are flat surfaces, that is why it is named surface area. Hence, surfaces. Surface area. Ah, you get it? Yes! So that's how we got 88 as our answer. However, the surface area of a square prism is a little different because its 2 bases are squares and they are not oblongs. But it is a prism, obviously, so it needs to have its own surface area. This is the side length A, and this is also the side length A, indicating that these are the same length, and therefore makes a square. And this is H, or the height. The surface area of a square prism equals 2a squared plus 4ah. So it's basically 2 times a squared plus 4 times a times h, or the height. So, let's substitute some numbers. Let's say a is 2 and h is 5. We should get 48 as our answer. Why do we get 48 as our answer? Great question, Byron. Good job. Why, thank you. You're welcome. So we got 48, but why? Well, we got 48 because we know that the surface area of a square prism is 2a squared plus 4ah. So if we do a little bit of math here, 2 times 2 is 4, and 4 times 2 is 8. 4 times 2 is 16, and 16 times 5 is 80. Wait a second. That's wrong. Oh, yeah. I made a mistake. Sorry, Byron. Great job. Wow. Because 80 plus 8, be careful, is not 48. Let me try that again. Sometimes equations have to be solved one certain step at a time. Let me try again. Right, I could do this. It's just solving. All right, 2 times 2 is 4, and 4 times 4 is 16. Because when there is an exponent of 2, you cannot multiply 4 by 2. You have to multiply 4 2 times. So 4 times 4 is 16. Then 4 times 2 is 8, and 8 times 5 is 40. 40 plus 16. Oh, darn it! That's wrong, too. I have to try and try again until I get it right. Okay, let's get this straightforward. 4 times 2 is 8. 8 times 5 is 40. 2 times 2 is 4. 4 times 2 is 8. That's correct! Yay! Woohoo! I did it right, because 8 plus 40 is 48. So sometimes you have to solve the equation a different way instead of the same way, because that could confuse you. So yes, the surface area is 48, because 2 times 2 squared plus 4 times 2 times 5 is 48. So that's how we got that answer. And finally, the surface area of a cube is pretty easy. The surface area of a cube is 6a squared, because it has 6 square faces. And to find the area of only one of the faces, we would have to multiply 1 by a squared. However, since it has 6 faces in total, we will have to multiply 6 by a squared. Let's say that a is, I don't know, maybe 6 as well. Let's see. Then we would get a surface area of 216. What? Because 6 times 6 is 36. And 36 times 6 is 216. So the surface area of the cube is 216. Because the surface area of any cube is 6a squared. 6 times 6, again, that's 36. And 36 times 6 is 216. So the surface area of the cube is 216. Because 6 times 6 squared equals 216. Or in other words, 6 times 36 equals 216, not to get you confused. So the surface area of a cube is 6a squared. And for this reason, since it does have faces, a cube is a prism. A cube is a special kind of rectangular prism that has all of its faces squares. Okay, well, unfortunately, that was it from us today, but it was a pretty good and educational video. I hope you enjoyed this video about the nets and surface area of lots of different kinds of prisms, including rectangular prisms, square prisms, and even cubes. Even cubes are prisms. Yes, cubes are a special kind of prism, a rectangular prism, or a cuboid, because a cube is a cuboid because it is a special kind of rectangular prism, and a cuboid is a rectangular prism. See you guys later in the next video. Bye, everyone! Bye! Tweet, 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 tweet. Hey, wait for me!